Hello and welcome back. In this video we're gonna talk about some sets. But before we can begin, let's firstly define what a set is. A set is any number of the form x square root of a where x and a are the elements of natural numbers. This is a definition of a set. Okay, now let's move to the laws of sets. Laws of sets. Why the laws of sets? Because you want to see how sets, like any number, behaves under multiplication and division, to name but some. First of all, when we have a square root of a and it is multiplied by square root of b, this is the same as square root of a times b. Okay, so for example, if I have square root of 4 times square root of 16, we all know that square root of 4 equal to 2 times square root of 16 equal to 4, which gives us 8. But let's say this equal to square root of 4 times 16 equal to square root of 64. This also equal to 8. This is the first law of sets. Okay, let's move to the second one. The second one says square root of a divided by the square root of b equal to the square root of a divided by b. Okay, we can just look at it again. Let's say square root of 4 divided by square root of 16. Square root of 4 equal to 2 divided by 4 equal to 1 over 2. Okay, let's say equal to square root of 4 divided by 16 equal to 1 over 4, and the square root of 1 over 4 equal to 1 over 2. Okay, so another law of sets says that the square root of x equal to x to the power 1 over 2. Okay, now we are done with the laws of sets. Let's move to exponential equations. Exponential equations. What is an exponential equation? An exponential equation is any equation whereby an exponent is the unknown value. When we talk about unknown value, we talk about the x, y, z, to name but some. For example, an example of an exponential equation will be 2 to the power x equal to 4. Okay, so if we are told to solve this equation 2x equal to 4, we can clearly see that 2x equal to 4 equal to 2 squared, and whenever you have two powers with the same base, you do what? You keep the base, you equate the exponents, x equal to 2. Okay, now suppose that you have something of this form: 5 times 2x plus 1 equal to 80. Okay, so the first thing you're gonna do is to divide both sides of the equation by 5. And this 5 cancels this 5. We have 2x plus 1 equal to 16. And 16 can be written as 16 equal to 2 to the power of 4. We have 2x plus 1 equal to 2 to the power of 4, and we have the same basis. We can equate the exponents. X plus 1 equal to 4, then x equal to 4 minus 1, x equal to. So this is our final solution. Okay, let's move to the next example. Let's say we have 2 to the power x plus 4 to the power of x equal to 6. Okay, for this one, we have 2 to the power of x plus 4 equal to 2 squared to the power of x equal to 6. And we have 2x plus 2x, and this 2x is squared. Let me say minus 6 equal to 0. So we cannot take out 2 to the power of x as a common factor, because if we take 2 to the power of x as a common factor, we're going to be left with 2 plus 2 to the power of x equal to 6. And you cannot solve this one. So what are we going to do to solve it? Okay, we're just going to say we let 2 to the power of we're going to let 2 to the power of x equal to k, so that whenever we see 2 to the power of x, we can put k, and this equation will be k plus k squared minus 6 equal to 0. And this will be k minus 2k plus 3 equal to 0. And k equal to 2 and another k equal to negative 3. So because we were told to solve for x, not solve for k, what we're going to do is that 2, because we have let 2x equal to k and our k equal to 2, 2x equal to 2. And 2 is the same as 2 to the power of 1. Then we have two powers with the same base. We keep the base, you equate the exponents. And also we have 2 to the power of x equal to negative 3, and this one we have no solution. Okay, thank you guys. See you See you later.